Hello, testing, testing. I think the mic volume is good. Hello, hi Krishna. Hi Karun, how y'all doing? Hello. Hey Rohan. Today, we're doing something very different today. Are you guys ready for some pain? Oh, we're doing Google interview questions now. Oh, this is gonna be so pain. Hi Shinnok, how you doing? Rohan. Yeah, we're done doing Microsoft questions. We've moved on. Two-sum. We don't need to do two-sum, right? Let me zoom this in. Two-sum is just for every element, maintain a hash set, right? Or one hash set. Minimum number of increments on... Oh, it's a hard problem. Should we start with a hard problem? Sure, let's do a hard problem. 1526. Who knows? This might be the only question we do today. Leetcode 1526. Oh no. Can you feel it? We're probably going to spend the entire day on this, huh? Minimum number of increments on subarrays to form a target array. Increments on subarrays to form a target array. Okay. You are given an integer array target. You have an integer array initial of the same size as target with all the elements initially zeros. In one operation, you can choose any subarray from initial and increment each value by 1. Return the minimum number of operations to form a target array from initial. The test cases are generated so that the answer fits in a 32-bit integer. Oh, Jesus. Target is this, right? Okay. What is our initial though? Oh, with elements initially zeros. Got you, okay. So in the example here, we start with all zeros. Increment 0 to 4. Okay, so increment everything. Increment from 1 to 3. Okay. Increment just 2. Okay, that makes sense. Sure. Example 2 is... Okay, you start with all zeros. You increment everything by 1. You increment the leftmost by 2. The rightmost by 2, I mean, and then left. Okay. Okay, I'm starting to see the pattern here. Everything zeros, increment by 1. Okay, sure. Is it bit manipulation? I'm not sure if it's bit manipulation. It's given as an array. Ooh, how do we do this? How do we do this? Is it time to write some pseudocode? Okay, if I can't get this in like 10 minutes, I'll actually look at the solutions. I'm not gonna waste all my time trying something that doesn't work. So we start off with all zeros, right? Like 0, ... Okay, so I mean, logically, from just like pure human intuition, how do we know that we can get from like 0, 0, 0 to 1, 1, 1, that we could do this? Do we find the minimum? Is that what we do? The minimum? Largest increment window? Largest increment window. I see what you're saying for this one, but Would that work for this one? You have like 2 islands of things to increment. Okay, you know what? Extremely brute force way. We would do one pass over here and just make a note of everything. Store all the indices in like a hash map or something that are greater than me, you know? Yeah. Did we just literally do that? I think an extremely brute force method is just keep iterating through the entire array. And then comparing what the initial to target is. This is the initial, by the way. Initial to the target, and then keep storing like yeah, keep storing what needs to be incremented, I guess, the indices. So like iterate through target and initial. Store the indices in a hash set of what needs to be incremented. Actually, no, you might be onto something, Krishna. Maybe we do have to track the largest increment window. So do we go through everything and then we stop when we go through something that's, you know, that does not need to be incremented? It's pretty greedy, isn't it? So we do this only for a continuous subsequence, I guess. Just basically we stop when we reach an element that does not need to be incremented. Yeah, okay. Huh. Hold on, maybe we don't need to stop. We just like increment a counter if, you know, not continuous. Okay, I'm starting to get an idea here. 1, 1, 1. Yeah, okay. Sure, we don't need to. Yeah, we don't need to do it separately. And then after that, we increment the initial based on hash set. I feel like that's a plan, no? So we have an initial, we keep iterating through it and comparing it to the values of target. We store the indices that need to be updated in a hash set, and if every time we need to skip a index, we increment our counter. Yeah. Count our operation count, I guess, starts off at 0, and every time we start an iteration, or every time we skip a number, our operation count increments, and then we increment initial based on the indices we stored in the hash set, and then we compare it again to target. Yeah, okay, I think that's a plan. I don't know, I think I'll try this. It's pretty brute force, but that's the best I can think of right now, literally. Okay. Is there a better way to do this? I'm thinking like, can we do this 2 pointers? It would maybe work here, but when it splits off into like 2 islands over here, or multiple islands, it probably won't work. Oh, dude, what if instead of maintaining an initial thing, what if we subtract from target instead? Like if we're given like this, we decrement 1 every time. That could work too. Huh. I mean, I don't see like a strong advantage to that over like simulating an initial. But yeah, should we do that? It might be easier to detect like places that are not continuous, you know? Wait, we wouldn't need a hash set too to maintain what indices need to be incremented. It's just everything that's not 0, right? Wait a minute. This might be actually simpler. Okay, so scratch this. We still maintain an operation count, but we iterate through the target, and that's it. Yeah, okay. So every time you start iterating, operation count plus plus, and also whenever you come across a 0, yeah, whenever you come across a 0, you increment the counter too. Come across 0, then operation count plus plus as well. Because that means you don't need to increment or decrement it. And then instead of incrementing, you decrement each by 1 unless it's a 0. Yeah, okay. You know what? I think that works for me. It's still pretty hand-wavy. I don't understand it completely, but I think it's a start that we can go off of. Okay, so let's see. If I cannot get this by 9:30, I'll probably take a look at the solutions because otherwise I'll waste too much time. Okay, here we go. Int operation count is equal to 0. Okay, so what do we do here? We somehow need to keep decrementing target. I have no idea what the stop condition is going to be. I don't know. Let's just do the old Boolean. Keep iterating. Iterating is equal to false. While we need to keep iterating. Oh, this should be true. So while we need to keep iterating, we'll worry about the stop case in the future. While we need to keep iterating, for every int I equals 0, we're basically iterating through target. Iterate through target. Well, I is equal to 0 and I is less than target.length I plus plus. Okay. Oh, like we said earlier, every time we start an iteration, operation count plus plus. Because we're starting one operation basically. Okay, what do we do here? Okay, I'm starting to see, what if we have like 0, 0, 0, 0, and then 1, 2, 3, you know? We don't need to operation count plus plus for each of these, right? Okay. That's something to think about. Okay. Okay, so while I is equal to 0, okay, so if target I is equal to 0, we do something, right? I think I'll worry about that later. Else, if it's not 0, then target at I minus minus, we decrement our stuff. Okay, so this is kind of tricky. If we've already started a operation, should we keep a boolean? Would that help us? Like boolean, like we're already in the process of an operation. In operation is equal to false. Okay, maybe that can help us. So maybe we shouldn't start the operation. Maybe we shouldn't increment the operation count in the beginning because, you know, what if we have a bunch of zeros in the beginning? We've already started an operation. Yeah, okay. So if the target is equals to 0, I guess we continue. Oh, okay, then in operation is equal to false. We stop our operation. Else, yeah, okay. So if we've not already started an operation, yeah, okay, so if we see a non-zero number, non-zero, and we've not already started an operation, that means we need to start an operation, right? Okay, sure. So operation count plus plus, and then in operation is equal to true. Okay, would this work in this case? So over here, we keep setting in operation to false and continuing. We get to 1, and we're like, okay, we're not already starting a operation. So operation count plus plus, we get to 2. It's a non-zero. We are in an operation, so we skip this if clause, and minus 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 minus. I mean, it sounds fine to me. Let's do a sanity check, yeah? So let's return -1 just as a bogus value first. I still don't know what the stop condition is. I guess if we ever increment something, if we ever decrement something, I guess, keep iterating is equal to true, keep iterating is equal to true. Else, if we never decrement anything, if we never touch anything, then it's false. Okay, sure. So for now, we'll set keep iterating equal to false in the beginning, and then if we ever, you know, manipulate anything, we set it back to true because we need to check one more time. Okay, sure. I think for every loop, let's print out system.out.println. Let's print out what our new target is. Okay. Arrays.toString target. Is this even gonna work? Oh look, we print out something. I think we're on the right track. Look. 1 2 3 2 1 gets converted to, yeah, we decremented everything by 1. We decrement this section by 1, so we get that. Then we 0 0 0 0 0 0. You know what? We might be on the right track here. To decrement everything by 1. Decrement everything by 1 again. Okay. Okay, it looks fine so far. The tricky part is actually, well, you know, counting the stuff. Should we print out what our operation count is so far? system.out.println op count plus operation count okay. Oh look, we're right. It's 3. But that's the really simple case. Excuse me, what about case 2? 4? Oh, that's not good. Oh, 7. Wait, did we actually get it? Did we actually get it? Wait. Operation count. That's pretty crazy. We got it, boys. At least the run test. Oh, is this gonna be one of those cases where we pass all the run tests, but the submissions is we don't pass the submissions? Submit. Rohan says, good night, brother. All the best with the stream. Time limit exceeded. Ah. Okay. Really love your content even though I don't understand code. Thank you. Okay. Yeah, this is too slow. End time. Alright, beats me, guys. I think it's 9:30, okay. Yeah, I feel like we're not on the right track, are we? If it's time limit exceeded. I don't know how to optimize this any further. Wait, is there a way we can optimize this? I don't know. Okay. Let's take a look at the solutions. I'm pretty sure we're not on the right track. Apparently end time is not fast enough. So let's see what they have here. There's no freaking editorial for this. No. Math and stack. Wall of bricks, detailed explanation. Which one should I be doing? Monotonic stack to greedy solution. Okay. Think of the numbers like building heights, and we are constructing layer by scratch. Building the largest building before us forced us to already build the smaller one we're on now, so no extra work. If we want to build something even bigger, okay. What are people doing over here? The greedy solution. Sure, I'm interested in the greedy solution. Oh, this looks alarmingly simple. Since we forced to work on adjacent buildings, the only comparison we need is to the building prior. Thus, the monotonic stack can be scrapped, and we can see at which points we need to do extra work. Min number operations. Operations is 0. Previous height is 0. What in the world? For every height in target, okay, so for every element in target, if the height is greater than the previous height, operations plus equals height minus previous height. Oh, yeah, if I'm taller than my previous height or previous number, then I'm guaranteed to, to do extra work on myself, right? I need to spend at least an extra operation on myself. Operations plus equals to height minus previous height. Previous height is equal to height. Wait, what? If height is greater than previous height, if my current height, operations plus equals height minus previous height. I mean, that makes sense. This part makes sense. What about the previous height? Oh, okay. My previous height is equal to current height. Hold on. Literally O(n) time O1 space. That's insane. Let's map this out, shall we? What's the example they gave us? Target is equal to this. Okay. So what happens in this case? Well, previous height. Sure, let's store our previous height is equal to 0. And our operations is equal to 0. Okay, so current height for every, okay, so let's say we're on 1 right now. If height is greater than previous height, which is 0, operations plus equals height minus previous height. Yes, we do need 1 operation on this. Excuse me. Previous height is now equal to height, which is 1. I see. So we're assuming we built up to 1. Okay. Next height is 2. Is it greater than 1? Yeah. So obviously we need extra operations to build it up. Operations plus equals to 2 minus 1 is 1. That makes sense. 3. We're on 3 now. Previous height is 2. This is making kind of sense actually. Okay, so we're on 3. Height is greater than previous height. So we definitely need an operation over 2. Okay, so 1 again. Previous height is now 3. We look at 2. Is height greater than previous height? Nope. Okay, so we just continue. Apparently we fill it up during, the 2 over here before. Alright. Previous height is 2. Operations. Wait, did I mishandle this? 1, 2. Should be 2, right? 1, 2, 3. It should be 3. Okay. So we get to 1 here. Previous height is 2, so we do nothing. Okay. I'm really curious. What happens if we have like 3 over here? 3. If height is greater than previous height, yes, the operations is equal to 3 minus 1, 2. Okay. You know what? That makes a lot of sense, actually. Yeah. Okay, that makes sense to me intuitively. So let's get rid of all this garbage. Man, greedy solutions. Makes you feel so dumb sometimes. So literally, we have an int operation count is equal to 0. Previous number is equal to 0 for every single int num in target. Okay, what do we do here? So if my current num is greater than my previous num, that means I need some extra operations to build it up that wasn't included in the previous operation. So operation count plus equals my current num minus the previous number. Yeah, okay. And else, if I'm smaller than my previous, that means my height was covered during its build-up as well. So yeah, okay, sure. And then you set the previous num equal to the current number, yeah. And then you return operation count. Num minus previous number. Oh, I forgot a semicolon. That is stupidly simple. It almost makes me mad. Jesus. Somebody got it in 2 milliseconds. What the heck did you do? Min is equal to 0. CTR 0, okay. If current is greater than min, he did basically the same thing as me. Okay. That is like insanely simple. Alright. Okay, I'm gonna note this question down and write this question down for review. So what question is this? Leetcode 1526. This is one of those questions where if you know the trick, you know it. Otherwise, you're kind of screwed. I want to read what the stack solution was. Okay. If we want to build something bigger, then we need to calculate how much extra work is needed, which we do by saying what's the difference we need to make up for when compared to the building prior. Okay. Okay, so this is the stack solution. How did they get from the stack solution to the greedy solution? Operation to 0, monostack. What the heck is a monostack? What is a monostack? Maintains its elements in a specific order. Monostacks ensure that elements inside the stack are arranged in an increasing or decreasing order based on their arrival time. Based on their arrival time. That makes no sense to me. Monotonic increasing stack, monotonic decreasing stack. Okay. So it's a stack that maintains order. Okay, so it sorts it, I guess. Huh. For every height in target, work is equal to the max of 0, my current height minus what is this? What is monotonic stack? Elements are placed in decreasing order from bottom to top. Each new element added to the stack must be smaller than or equal to the one below it. If a new element is greater than top of the stack, then we remove elements from the top of the stack until we find one that is greater or equal to the new element or until the stack is empty. This ensures that the stack always stays in decreasing order. Oh yeah, so what happens if you if you try pushing an element that's not in order? We remove elements from the top stack. Oh shoot. So you pop elements. I see. Okay, Okay, so work is equal to monostack the top at first. Okay, so I guess this is, you're just getting the top element. Height minus decreasing monotonic stack. So it's always in decreasing order from bottom to top, I suppose. Okay. So you're always tracking from decreasing to increasing. Okay. Sure. Okay. So you're always just storing the least one before you? Height is equal to height minus the sort of least one before me, kind of. While monostack in H is greater than or equal to monostack in H greater than or equal to the previous in stack, I guess. Pop. If current building is larger than the previous ones, it couldn't have been built altogether. Yeah, that's true. You know what? Whatever. I understand the greedy solution. I think that's good enough. Okay, next problem. Merge strings alternately. We did that recently on stream, right? Merge strings alternately. Yeah, there's already a solution here. Merge the strings by adding letters in alternating order, starting with word 1 if a string is longer than the other two. Okay. Yeah, you just keep 2 pointers, right? In a string builder. You just put A and then P, P, Q, C, R. Okay, sure. And then in the end, if any of them is still not empty, I guess, append the rest to it. Yeah, that's not bad. We did that on stream too. I don't want to do another hard question. Let's do this next time. Create hello world function. We've seen that before. That's not a Java question. Merge intervals. Have we done this before? Leetcode 56. I recall it gave us a really hard time, so let's do this one. Leetcode 56. Leetcode 56. Yeah, I saw this before. I don't remember the solution though. I recalled that this gave me a really hard time. Given an array of intervals where intervals equal to start, and merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Oh man. They're not guaranteed to be given in sorted order, is it? 1, 3, 2, 6, 8, 10, 15, 18. Hold on, let me hydrate. My throat is kind of going out. Excuse me. Okay, so how do we know 1, 3, and 2, 6 go together? 3 happens between 2 and 6, right? Or 3 is greater than... Yeah, 3 is between 2 and 6. Alright. 8, 10, 15, 18. Yeah, okay, sure. Intervals 1, 4, 4, 5. Okay. 4 is greater than or equal to 4, 5. And it's less than 5, too. Okay. So I assume the intervals are not guaranteed to be given to us in, order. So I think one step is we should first sort our intervals by the start time. And then for each interval, I guess. Oh, this is tricky. For every interval, okay, if the next interval, if my end is less than the next interval's end, is that how we do it? If my end is between the next interval, or what if we need to combine multiple intervals? I guess while my end is less than the end. Ooh, this is kind of tricky. Let's do a really, let's make up our own really annoying example. Okay, let's say we have this, right? 1, 3, 2, 6. Let's say we have, I don't know, what? 9, 1, 9, 2, 6. Yeah, okay, so these should be combined together. How do we know that they combine together? Oh. Wait, yeah, how? Nine is greater than 6. When we know for sure that this next interval starts after me. Oh, this is tricky. How do we know when to merge intervals? If the next is... This is actually so tricky, what the heck? If the next interval ends... Okay, how do we know whether to merge the next interval if next, like end, is less than my end? Okay, and then we need to merge this one too. How do we know to merge this one? 9 is definitely greater than 8. So also if the next is start is less than my end. Ooh, my brain. It hurts. Well, so here, this is if the next interval's end is less than my end, if next's start is less than my end, I mean, this is true for this one too. If the next start is less than my end, then, oh, I know. The new end is equal to the max of my end and the next's end. Is that true? So my end is definitely greater than my next's start. So new end is equal to 9, okay, very nice. Next is this one. Is it start less than my end? Yeah, so max is equal to end. Current end is equal to 10, okay. is next to start 15 less than, okay. I think I figured out the algorithm. It's this. Yeah, okay. Cool. So the plan is still the same. We sort all the intervals by the start. And we probably need to convert it to a list, right? This is the annoying thing with Java. Oh. Yeah. Sure. And then we'll merge everything into lists. Lists, 2D lists. And then we'll convert them back into an array. Okay. Let's try that. Arrays dot sort intervals. What do we sort it by? Comparator dot comparing interval. I forgot how comparators work. It's always an issue. Is this how you do it? Interval, we compare it by interval 0? Like that? Let's do a sanity check. System.out.println arrays.toString. Oh, you can't do this for 2D arrays, can you? So for every single interval, my brain, it hurts. Interval in intervals, you print it out. Arrays.toString, the current interval. Okay, let's see how much I remember from comparators. Run. Missing return statement. Let's return null just as a bogus statement. Okay. 1, 3, 2, 6, 8, 10, 15. Looks good. 1, 4. Okay. These are already in order though. Let's make sure the sorting is actually working. Let's put the 15 in the beginning. Bam. Oh, shoot. I didn't mean to submit. It's not gonna work. Cool, it's sorting. The sorting is working. Wow, it's a miracle. Remember how comparators work. Okay. Next up, we need a list. A list of lists, yeah. Of integers. Result is equal to new array list. Whew, okay. Now the tricky part. We need to iterate through all the intervals and then combine them somehow. Let's do for int I is equal to 0, while I is less than intervals dot length I plus plus. Okay, so the current interval is equal to intervals I, and again, our merge condition is if my, well, we can reword this, like, aka my end is greater than the next's start. Okay. So First, we need to check if we're inbounds, right? If we even have a next interval. If I plus 1 is less than intervals.length, which means we have a next. Next. The next interval is equal to intervals I plus 1. So if we need to track our current end, right? And current end is equal to the current interval 1. Okay, so yeah, let's check our next interval. If the current intervals end, no, if the current end, yeah, the current end is greater than the next interval start, then the current end is equal to the max of the current end and the next's end. Next. Yeah, this is kind of complicated. Should this be just one if statement? This has to be a loop somehow, right? In case we merge multiple. So we'll probably do while I plus 1 is inbounds and oh, this is so complicated. So we get the next interval. And the next intervals and while the current end is greater than the next intervals start. So we don't need this anymore. In that case, you keep updating your current end. Okay. With your current end and the next intervals. Okay. Oh, this is either gonna work really well or it doesn't work at all. God damn. Okay. So list, integer, let's make a new array list, yeah? So list, integer, what do we call this? Interval? I'm blanking on what to call this. The result element is equal to new array list. You can just input a array inside an array list, right? Java array literal. Think I should know how to do this, but is this gonna work? So current 0. And you know what? I'm not gonna bother with the fancy constructors. I'm just gonna do result interval dot add the current interval start and result interval dot add the current end. All right. I just realized we should probably increment I, right? So I plus plus over here, and then here we just do I1. Yeah, okay. Oh, yeah, this is either gonna be really... This is either gonna work really well or really badly. Okay, so let's print out what our result is. Result for every list integer result lm in the result. Print it out. Out.println result element. We don't need to print this out anymore. Okay. Moment of truth. It's not gonna work, but did it actually work? 1, 6, 8, 10, 15, 18. Ooh. Ooh, did it actually work? I think it worked. Ho-ho. I think it actually worked. We just have to convert this into arrays now. Cool. Alright. And result array is equal to new int the result dot length size with 2 length each. Okay. For int I is equal to 0, I is less than result dot size I plus plus. Okay. List integer. So we get the interval as a list first, and then we store it as an array. Integer result element is equal to results.get I. And then in result array, we added in, so at I 0 is equal to result lm.get 0. And then we do the same for the end of the interval. 1, 1. All right. And then we return result array. We're probably going to lose lots of time on, you know, list to array conversion, but oh well, it works, I think. If we don't get any compilation errors. Yeah, cannot find simple. No, output is nothing. Why? Wait, why? It's absolutely nothing. New int result.size 2. Is there actually nothing here? I am so confused. Result array is equal to new int result.size. Wait, why? Let's print out result array then. Wait, I'm actually so confused. Why is it not printing out correctly? What's even result.size? Result is that. Arrays.toString result array. I just realized y'all couldn't see my screen the entire time. Goddamn. Is result.size actually just nothing? Result.size run 0. Why in the world is it 0? Deepak says hi. Hello. Hi Deepak, how are you doing? Result interval.add. Oh. Result.add. Result interval. Because we never added it in. Okay, that makes more sense. Run. Fine, how about you? I'm doing good. I've been getting lots of nice sleep recently. Completed some final interview stages. Yeah. 1, 4, 4, 5. Result interval. Wait, this is weird. So we did this correctly. Thank you. Wait, I swear we did this correctly. What? Really? Current n is greater than equal to, maybe? There we go, it worked. I don't know why it worked in the beginning for whatever reason. Submit. And it's 5.27%. It's because we have a print statement here somewhere, right? Where's the print? Oh, that's it. Dang. It's because of the list to array conversion, isn't it? That's really slow. Alright, well, at least we got a solution on the board. Okay, you know what? I think I'm fine with this. It's the, I believe it's the list to array conversion that's getting us. We can look at this next time, how to optimize it. Huh. Alright, let's move on to system design study then. We're probably not going to get far this time because my brain is kind of cooked right now. But I'll try my best. Okay. We recently read Design YouTube, right? Let's look at Design Google Drive. Hey, that's pretty on theme with today. Google interview questions, Google Drive. Okay, so again, this is the part of the stream where I'll probably talk a little bit less because I'm taking notes. Speaking of notes, this is my notebook. Okay, chapter 15, Google Drive. What do you guys think Google Drive is? I think it's just a bunch of... Is it blob storage also? Actually, I have no idea. File storage and synchronization service. Okay. Yeah, which part of Google Drive exactly are we doing? What are the most important features? Upload and download files, file sync, and notifications. Notifications? Do people actually care about notifications in Google Drive? This is both a mobile app and web app. What are the supported file formats? Any file type. They must be encrypted. 10 gigabytes or smaller. 10 million daily active users. Drag and drop a file into Google Drive, download files, sync files across multiple devices. Okay. See file revisions, share files, send a notification when a file is edited, deleted, or shared with you. Do people actually use this? I never really recall this being a feature. Yeah, I was thinking about this. Google Doc editing and collaboration. Okay, back of the envelope estimation. 50 million sign-up users and 10 million daily active users. 10 gigabytes free. Upload 2 files a day. Average file size is 500 KB. 1-to-1 read-to-write ratio, okay. Total space allocated is 50 million times 10 gigabytes, 500 petabytes. QPS for upload API. What is it? Queries per second? More than 10 million times 2 uploads. Okay, that's the number of active users, 2 uploads a day in times, divided by 24 hours. Oh, I see. Divided by 3,600 seconds is equal to 240. Okay, so 240 queries per second. Okay. Peak queries per second is double that, 480. Okay, understood. A web server to upload and download files, a database to keep track of metadata like user login info, files info. We spend a few hours setting up an Apache web server, MySQL database, and a directory called a drive. Okay. Under the drive directory, there's a list of directories known as namespaces. Okay. Oh, okay. So user 1. Huh. Interesting. So we use one server. We're using its file system to do this. Every user gets to their own directory. Okay. Okay. Let me hydrate again. Okay, so there's 2 types of upload types. One is simple upload, resumable upload. Sure. Send the initial request. Reified says, "Hi chat, how's it going?" Hey, I'm doing good. I got some nice sleep last night. I think I scored at 89 on Pokemon Sleep. Yeah. I'm practicing Google interview questions on Leetcode now. And on theme for today, we are learning how to design Google Drive. Yeah, how are you doing? How is life? Download path, get file revisions. Okay. All the APIs require user authentication and use HTTPS. Move away from a single server. As more files are uploaded, eventually you get the space folder. Yeah. Shard the data so it's stored on multiple storage servers. Reified says, "I'm fine, thank you." Nice. Okay, so you shard where you store the files based on user ID, okay. Potential data losses in case of storage server outage. You ask around and your backend guru friend Frank told you that many leading services use Amazon S3. You decide to do some research to see if it is a good fit. Okay. S3 supports same region and cross-region replication. Redundant files are stored in multiple regions to guard against data loss and ensure availability. A bucket is like a folder in file systems. Okay, yes. Bucket. Okay, sure. Data can be replicated on the same region and cross-region. Very cool. After putting files in S3, you can finally have a good night's sleep without worrying about data losses. To stop similar problems from happening in the future, you decide to do further research on areas you can improve. Here are a few areas you find. Load balancer to distribute network traffic. Sure. Web servers. Reified says S3 is a really common way to short sentence. Wait, where? You really make it as in that way? Wait, I don't understand what that question means. Metadata database, move the database out of the server to avoid single point of failure. Set up data replication and sharding. S3 is oh, you want me to describe S3? S3 is like a file system storage for Amazon. Well, in AWS, I guess. When I was working as a developer, I just thought of it as Google Drive for developers. Yeah, you can store files, I guess, in buckets or directories, I guess. And I'm just learning that it supports replication. It supports, yeah, replication of your files cross-region and in-region too. So, yeah. Gibray says, are you a student? Nope, I'm not a student. S3 is Simple Storage Service. Yeah, I think that's what it stands for. Oh, is that what you were asking me? What does S3 stand for? Okay, cool. So the user goes to the load balancer, to our API servers, into our file storage, metadata DB. Wait, what's the file storage for? Is this the like the servers we used before to store them in a bunch of folders? And then servers are for redirecting to the correct one? Verified says that's really common way to make short option for, oh, I see what you're saying. No, that's not a common way for abbreviation in English. S3 is just, that's the way they chose to name it. I don't think we do that in English. Let me think. What other crazy abbreviations are there? DynamoDB is DDB? No, okay. K Kubernetes. Wait. Kubernetes. Abbreviation. Huh. That's really interesting. Maybe it's just the product name. That's not a really common way to abbreviate stuff. What other products are named like AWS S3, where the abbreviation is how many times the letters appear? BigQuery, IBM DB2, no. 3PAR. All right, I think S3 is by itself. It's not really, yeah, it's pretty unique in naming. I mean, the alternate would be to name it SSS, right? Which is kind of awkward. I-18N, Internationalization Framework. Oh, that's that one Leetcode problem we did. Is that actually a real thing? Conflicts happen from time to time. When two users modify the same file or folder at the same time, a conflict happens. Okay. First version that gets processed wins, and the version that gets processed later receives the conflict. Okay. Users, okay, that's a really simple way to handle version conflicts. That's not how Google Doc works, is it? High level design, okay. A11Y for accessibility. Oh. Why is it abbreviated like that? Why is A11Y for accessibility? Oh, it's literally 11 letters. God damn. Alright. Okay. Let's see what happens here. So a user... What the heck is a block server? Is it like the chat server where you get one designated server to serve your... Yeah, I don't know what that is. Let's keep reading. Block servers upload blocks to cloud storage. Block storage, referred to as block level storage, is a technology to store data files on cloud-based environments. A file can be split into several blocks, okay. To reconstruct a file, blocks are joined in a particular order. Huh, okay. So, this is how we upload files, I guess? S3 named block storage. Okay. A file is split into smaller blocks and stored in cloud storage. Oh no, this is S3, right? So, okay, this is interesting. I guess it's kind of like when we were learning about YouTube, right? The GOP thing. GOP. Like when we split a video into multiple seconds, I guess we're splitting a file into multiple chunks again and then just uploading it. So we can probably do it in parallel too. And also, it's easier to handle retries, I guess. If one block fails, we only need to retry that block. No need to retry everything. Block servers are used to chunk big files to upload/download. I see. Makes sense. Cloud storage, that's probably S3. Cold storage, what the heck is cold storage? Is a computer system designed for storing inactive data, meaning files are not accessed for a long time. Huh, okay. Is this a subset of the cloud storage? Okay, I imagine that they take it away from the cloud storage and put it in cold storage. Sure, okay. Load balancer, we know what that is. API servers, we know what that is. Cold storage is equal to archive. Oh, okay. Is cold storage also S3? Cold storage versus cloud storage. Oh, okay, so cold storage is lower storage costs, but retrieval times may be hours or days longer. A magnetic tape belt, most likely. Oh, I see. Amazon Glacier, Google Cold Line. I see. I see. So it's another cloud service too. But retrieval is like really expensive and storage is really cheap. Okay. Who knows how they implement it? Offline backup queue, what is this? Oh, okay, so the notification service. In case the user is not active, I guess. Okay. Design deep dive. Oh, okay. You know what? I think we'll continue with design deep dive next time. My phone is running out of battery too. Okay, that's it for today then. Thanks everyone for coming. Thanks. Is it Gebre? Gebre and Reified. I appreciate y'all coming. We are gonna continue tomorrow, I think. Am I gonna be here tomorrow? Probably. Alright, see you guys tomorrow. We're gonna be doing more Google interview questions tomorrow. See ya. Bye. Can I rate anyone? I'm always saying that. But there's no one I know on that streams in the morning like here. Okay, that's probably it then. Thanks everyone. Bye.